Hello, America. My name is Dylan John, and you are listening to the Neo-Fusionist Book Review. This is not your typical book review, as I make no claims to political or philosophical impartiality. This podcast uses the format of a book review to explore the premise of Neo-Fusionism. Neo-Fusionism is the merging of paleoconservatism with naturalism within the framework of the revitalization of the Republican Party. We will be exploring politics, philosophy, psychology, economics, and sociology through a wide variety of books published both recently and historically. Thank you for tuning in. So, in this episode, we'll be looking at On Human Nature by E.O. Wilson. This book is a kind of an overview of what was known about human nature. It's not a recent book. It was published in 1978. So that would make it 40 years old right now. A little bit older than 40. Regardless, he talks about the genetic process of evolution and the creation of human culture through evolutionary processes as a outspringing of evolutionary processes. And he gets into a little bit more detail about it than what we have looked at so far. So there's some pretty good stuff in here. I'm going to start reading right here on chapter 1. As you see, he opens up with a pretty good spot here. He says, quote, "These are the central questions that the great philosopher David Hume said are of unspeakable importance. How does the mind work? And beyond that, why does it work in such a way and not another? And from these two considerations together, what is man's ultimate nature?" We keep returning to the subject with a sense of hesitancy and even dread, for if the brain is a machine of 10 billion nerve cells, and the mind can somehow be explained as the summed activity of a finite number of chemical and electrical reactions, boundaries limit the human prospect. We are biological, and our souls cannot fly free. If humankind evolved by Darwinian natural selection, genetic chance and environmental necessity, not God, made the species. Deity can still be sought in the origin of the ultimate units of matter, in quarks and electron shells. Hans Kung was right to ask atheists why there is something instead of nothing, but not in the origin of species. However much we embellish that stark conclusion with metaphor and imagery, it remains the philosophical legacy of the last century of scientific research. No way appears around this admittedly unappealing proposition. It is the essential first hypothesis for any serious consideration of the human condition. Without it, the humanities and social sciences are the limited descriptors of surface phenomena like astronomy without physics, biology without chemistry, and mathematics without algebra. With it, human nature can be laid open as an object of fully empirical research. Biology can be put to the service of liberal education, and our self-conception can be enormously and truthfully enriched. But to the extent that the new naturalism is true, its pursuit seems certain to generate two great spiritual dilemmas. The first is that no species, ours included, possesses a purpose beyond the imperatives created by its genetic history. Species may have vast potential for material and mental progress, but they lack any imminent purpose or guidance from agents beyond their immediate environment, or even an evolutionary goal toward which their molecular architecture automatically steers them. I believe that the human mind is constructed in a way that locks it inside this fundamental constraint and forces it to make choices with a purely biological instrument. If the brain evolved by natural selection, even the capacities to select particular aesthetic judgments and religious beliefs must have arisen by the same mechanistic process. They are either direct adaptations to past environments in which the ancestral human populations evolved, or at most constructions thrown up secondarily by deeper, less viable activities that were once adaptive in this stricter biological sense. The essence of the argument, then, is that the brain exists because it promotes the survival and multiplication of the genes that direct its assembly. The human mind is a device for survival and reproduction, and reason is just one of its various techniques. Steven Weinberg has pointed out that physical reality remains so mysterious even to physicists because of the extreme improbability that it was constructed to be understood by the human mind. We can reverse that insight to note with still greater force that the intellect was not constructed to understand atoms or even to understand itself, but to promote the survival of human genes. The reflective person knows that his life is in some incomprehensible manner guided through a biological ontogeny, a more or less fixed order of life stages. He senses that with all the drive, wit, love, pride, anger, hope, and anxiety that characterize the species, he will, in the end, be sure only of helping to perpetuate the same cycle. Poets have defined this truth as tragedy. Yeats called it, in The Coming of Wisdom, "Though leaves are many, the root is one. Through all the lying days of my youth, I swayed my leaves and flowers in the sun. Now I may wither into the truth." The first dilemma, in a word, is that we have no particular place to go. The species lacks any goal external to its own biological nature. It could be that in the next 100 years, humankind will thread the needles of technology and politics, solve the energy and materials crisis, avert nuclear war, and control reproduction. The world can at least hope for a stable ecosystem and a well-nourished population. But what then? Educated people everywhere like to believe that beyond material needs lie fulfillment and the realization of individual potential. But what is fulfillment, and to what ends may potential be realized? Traditional religious beliefs have been eroded, not so much by humiliating disproofs of their mythologies as by the growing awareness that beliefs are really enabling mechanisms for survival. Religions, like other human institutions, evolved so as to enhance the persistence and influence of their practitioners. Marxism and other secular religions offer little more than promises of material welfare and a legislated escape from the consequences of human nature. They, too, are energized by the goal of collective self-aggrandizement. The French political observer Alain Peyrefitte once said, admiring of Mao Zedong, that the Chinese knew the narcissistic joy of loving themselves in him. It is only natural that he should have loved himself through them. Thus does ideology bow to its hidden masters, the genes, and the highest impulses seem upon closer examination to be metamorphosed into biological activity. He says, quote, "Innate sensors and motivators exist in the brain that deeply and unconsciously affect our ethical premises. From these roots, morality evolved as an instinct. If that perception is correct, science may soon be in a position to investigate the very origin and meaning of human values, from which all ethical pronouncements and much of political practice flow. Philosophers themselves, most of whom lack an evolutionary perspective, have not devoted much time to the problem. They examine the precepts of ethical systems with reference to their consequences and not their origins. Thus, John Rawls opens his influential A Theory of Justice with a proposition he regards as beyond dispute. In a just society, the liberties of equal citizenship are taken as settled. The rights secured by justice are not subject to political bargaining or to the calculus of special interests." Robert Nozick begins Anarchy, State, and Utopia with an equally firm proposition. "Individuals have rights, and there are things no person or group may do to them without violating their rights. So strong and far-reaching are these rights that they raise the question of what, if anything, the state and its officials may do." These two premises are somewhat different in content, and they lead to radically different prescriptions. Rawls would allow rigid social control to secure as close an approach as possible to the equal distribution of society's rewards. Nozick sees the ideal society as one governed by a minimal state, empowered only to protect its citizens from force and fraud, and with unequal distribution of rewards wholly permissible. Rawls rejects the meritocracy. Nozick accepts it as desirable, except in those cases where local communities voluntarily decide to experiment with egalitarianism. Like everyone else, philosophers measure their personal emotional responses to various alternatives as though consulting a hidden oracle. That oracle resides in the deep emotional centers of the brain, most probably within the limbic system, a complex array of neurons and hormone-secreting cells located just beneath the thinking portion of the cerebral cortex. Human emotional responses and the more general ethical practices based on them have been programmed to a substantial degree by natural selection over thousands of generations. The challenge to science is to measure the tightness of the constraints caused by the programming, to find their truth in the brain, and to decode their significance through the reconstruction of the evolutionary history of the mind. This enterprise will be the logical complement of the continued study of cultural evolution. Success will generate the second dilemma, which can be stated as follows. Which of the censors and motivators should be obeyed, and which ones might be better curtailed or sublimated? These guides are the very core of our humanity. They, and not the belief in spiritual apartness, distinguish us from electronic computers. At some time in the future, we will have to decide how human we wish to remain, in this ultimate biological sense, because we must consciously choose among the alternative emotional guides we have inherited. To chart our destiny means that we must shift from automatic control based on our biological properties to precise steering based on biological knowledge. Because the guides of human nature must be examined with a complicated arrangement of mirrors, they are a deceptive subject, always the philosopher's deadfall. The only way forward is to study human nature as part of the natural sciences, in an attempt to integrate the natural sciences with the social sciences and humanities. I can conceive of no ideological or formalistic shortcut. Neurobiology cannot be learned at the feet of a guru. The consequences of genetic history cannot be chosen by legislatures. Above all, for our own physical well-being, if nothing else, the ethical philosophy must not be left in the hands of the merely wise. Although human progress can be achieved by intuition and force of will, only hard-won empirical knowledge of our biological nature will allow us to make optimum choices among the competing criteria of progress. End quote. So he's very clearly heavily in favor of using science to uncover and unravel human nature. And he kind of makes a point about ideology a little bit when he goes after both John Rawls and Robert Nozick for opening their books with statements of rights with no empirical backing behind them and presupposes their existence as fundamental. So, yeah, he brings that back to David Hume in the very beginning. We'll probably be looking a little closer at Hume at some point. He's an interesting fellow from the Enlightenment. So now that we've kind of laid out some of the challenges facing us as we look at this type of examination of human nature, he begins in the next chapter to talk about heredity and the passing on of traits from parents to children and how that affects human nature. He says, quote, "Human social behavior can be evaluated first by comparison with the behavior of other species, and then, with far greater difficulty and ambiguity, by studies of variation among and within human populations. The picture of genetic determinism emerges most sharply when we compare selected major categories of animals with the human species. Certain general human traits are shared with a majority of the great apes and monkeys of Africa and Asia, which on grounds of anatomy and biochemistry are our closest living evolutionary relatives. Our intimate social groupings contain on the order of 10 to 100 adults, never just 2, as in most birds and marmosets, or up to thousands, as in many kinds of fishes and insects. Males are larger than females. This is a characteristic of considerable significance within the Old World monkeys and apes, and many other kinds of mammals. The average number of females consorting with successful males closely corresponds to the size gap between males and females when many species are considered together. These rules make sense. The greater the competition among males for females, the greater the advantage of large size, and the less influential are any disadvantages accruing to bigness. Men are not very much larger than women. We are similar to chimpanzees in this regard. When the sexual size difference in human beings is plotted on the curve based on other kinds of mammals, the predicted average number of females per successful male turns out to be greater than 1, but less than 3. The prediction is close to reality. We know we are a mildly polygynous species. The young are molded by a long period of social training, first by closest associations with the mother, then to an increasing degree with other children of the same age and sex. Social play is a strongly developed activity featuring role practice, mock aggression, sex practice, and exploration. These and other properties together identify the taxonomic group consisting of Old World monkeys, the great apes, and human beings. End quote. At a later point in that same chapter on heredity, he says, quote, "It is interesting to speculate that if people were somehow raised from birth in an environment devoid of most cultural influence, they would construct basic elements of human social life ab initio. In short time, new elements of language would be invented and their culture enriched." Robin Fox, an anthropologist and pioneer in human sociobiology, has expressed this hypothesis in its strongest possible terms. Suppose, he conjectured, that we performed the cruel experiment linked in legend to the pharaoh Psammetichus and King James IX of Scotland, who were said to have reared children by remote control, in total social isolation from their elders. Would the children learn to speak to one another? I do not doubt that they could speak, and that, theoretically, given time, they or their offspring would invent and develop a language despite their never having been taught one. Furthermore, this language, although totally different from any known to us, would be analyzable to linguists on the same basis as other languages, and translatable into all known languages. But I would push this further. If our new Adam and Eve could survive and breed, still in total isolation from any cultural influences, then eventually they would produce a society which would have laws about property, rules about incest and marriage, customs of taboo and avoidance, methods of settling disputes with a minimum of bloodshed, beliefs about the supernatural and practices relating to it, a system of social status and methods of indicating it, initiation ceremonies for young men, courtship practices including the adornment of females, systems of symbolic body adornment generally, certain activities and associations set aside for men from which women were excluded, gambling of some kind, a tool and weapon-making industry, myths and legends, dancing, adultery, and various doses of homicide, suicide, homosexuality, schizophrenia, psychosis, and neuroses, and various practitioners to take advantage of or cure these depending on how they are viewed. End quote. Not only are the basic features of human social behavior stubbornly idiosyncratic, but to the limited extent that they can be compared with those of animals, they resemble most of all the repertories of other mammals, and especially other primates. A few of the signals used to organize the behavior can be logically derived from the ancestral modes, still shown by the Old World monkeys and great apes. The grimace of fear, the smile, and even laughter have parallels in the facial expressions of chimpanzees. This broad similarity is precisely the pattern to be expected if the human species descended from Old World primate ancestors, a demonstrable fact, and if the development of human social behavior retains even a small degree of genetic constraint, the broader hypothesis now under consideration. End quote. So yeah, kind of listing off a whole array of different traits that humans have, particular to our species, that we could expect, that we find across all human cultures, and that we could expect a new human culture to adopt these particular property system, initiation systems, body adornment, dancing, all these different things that humans do. we could expect a new human civilization that sprung up with no contact to anyone else would have those same traits. So I think it's interesting because we're starting to get into specifics about what human nature is. Now that we've pretty well established that it exists, we can start to get in and look at the details. Later on in the Heredity chapter, he says, quote, "Hypergamy is the female practice of marrying men of equal or greater wealth and status. In human beings and most kinds of social animals, it is the females who move upward through their choice of mates. Why this sexual bias? The vital clue has been provided by Robert L. Trivers and Daniel E. Willard in the course of more general work in sociobiology. They noted that in vertebrate animals generally, and especially birds and mammals, large, healthy males mate at a relatively high frequency, while many smaller, weaker males do not mate at all. Yet nearly all females mate successfully. It is further true that females, in the best physical condition, produce the healthiest infants, and those offspring usually grow up to be the largest, most vigorous adults. Trivers and Willard then observed that according to the theory of natural selection, females should be expected to give birth to a higher proportion of males when they are healthiest, because these offspring will be largest in size, mate more successfully, and produce the maximum number of offspring. As the condition of the females deteriorates, they should shift progressively to the production of daughters, since female offspring will now represent the safer investment. According to natural selection theory, genes that induce this reproductive strategy will spread through the population at the expense of genes that promote alternative strategies. It works. In deer and human beings, two of the species investigated with reference to this particular question, environmental conditions adverse for pregnant females associated with a disproportionate increase in the birth of daughters. Data from mink, sheep, pigs, and seals also appear to be consistent with the Trivers-Willard prediction. The most likely direct mechanism is the selectively greater mortality of male fetuses under adversity, a phenomenon that has been documented in numerous species of mammals. Altering the sex ratio before birth is, of course, an entirely irrational act. It is, in fact, physiological. Mildred Dickman, an anthropologist, has tested the theory in the realm of conscious behavior. She has asked whether the sex ratio is altered after birth by infanticide in a way that fits the best reproductive strategy. Such appears to be the case. In pre-colonial and British India, the upward social flow of daughters by marriage to higher-ranking men was sanctified by rigid custom and religion, while female infanticide was practiced routinely by the upper castes. The Bedi Sikhs, the highest-ranking priestly subcaste of the Punjab, were known as Kurimar, the daughter slayers. They destroyed virtually all female infants and invested everything in raising sons who would marry women from lower castes. In pre-revolutionary China, female infanticide was commonly practiced by many of the social classes, with essentially the same effects as in India, that is, a socially upward flow of women accompanied by dowries, a concentration of both wealth and women in the hands of a small, middle, and upper class, and near exclusion of the poorest males from the breeding system. It remains to be seen whether this pattern is widespread in human cultures. For the moment, the existence of even a few cases suggests the need for a re-examination of the phenomenon with close attention to biological theory. Female hypergamy and infanticide do not recommend themselves as rational processes. It is difficult to explain them except as an inherited predisposition to maximize the number of offspring in competition with other members of the society. Research of the kind started by Dickman, if extended to other societies, will help to test this proposition more rigorously. If successful, it can be expected to shed light on the deeper mental processes that move people to choose one complicated course of action out of the many open, in principle, to rational choice. Human nature can be probed by other, more directly psychological techniques. behavior that is both irrational and universal should also be more resistant to the distorting effects of cultural deprivation than more intellectual, individualistic behavior, and less likely to be influenced by the frontal lobes and other higher centers of the brain that serve as the headquarters of long-term rational thought. Such behavior is more likely to be heavily influenced by the limbic system, the evolutionarily ancient portion of the cortex located near the physical center of the brain. Given that the higher and lower controls in the brain are anatomically separated, to some extent, we can expect to find occasional human beings whose rational faculties have been impaired, for one reason or another, but who continue to function well at the level of instinct. End quote. So yeah, you can really dig in pretty deep into how evolutionary processes have affected the behavior of reproduction, both instinctual, physiological, cultural. It's the effects of the different human biology of men and women has affected our culture and our brains and our bodies in many, many different ways that we will explore in this podcast down the road. I think it's a real interesting topic of study. And then in the next chapter, when he begins to talk about development, he says, quote, "As anticipated by evolutionary theory, behavioral development is channeled in the direction of the most generally mammalian traits. But what is the ultimate range of our potential? How far can human beings be moved across or even outside the mammalian channels? The answer must be sought in the study of individual development with special reference to genetic determinism." We have at last come to the key phrase, genetic determinism. On its interpretation depends the entire relation between biology and the social sciences. To those who wish to reject the implications of sociobiology out of hand, it means that development is insect-like, confined to a single channel, running from a given set of genes to the corresponding single predestined pattern of behavior. The life of a mosquito does fit this narrow conception perfectly. When a winged adult emerges from its pupal case, it has only a few days to complete a set of intricate maneuvers, leading to the deposit of a set of fertilized eggs in an organically contaminated water. Both sexes get swiftly to work. The whine created by the wing beat of the female, so irritating to the human ear, is a love song to the male. With no previous experience, he flies toward the sound. The whine of a female yellow fever mosquito is between 450 and 600 hertz, or cycles per second. In the laboratory, entomologists have attracted males simply by striking a tuning fork set at these frequencies. When a cheesecloth is placed over the tuning fork, some of the more excited mosquitoes attempt to mate with it. The female mosquito cannot afford to be quite so impetuous, yet the episodes of her life follow a rigid marching order prescribed by her genes. She seeks out human and other mammalian prey by their warmth, or, in the case of some species, by the odor of lactic acid emanating from the skin. Alighting, she probes the skin with two microscopic thread-like and sharpened stylets. The points are plunged through the skin in search of a blood vessel, much as oil prospectors sink a well. Sometimes they strike a vessel, and sometimes not. The female of at least one species of mosquito identifies blood by the taste of a chemical called adenosine diphosphate, found in the red cells. The only apparent significance of ADP among the hundreds of available blood constituents is that it serves as an immediately accessible marker. Other, similarly arbitrary sign stimuli guide the mosquito to appropriate ponds and smaller bodies of water where she can lay her eggs in safety. The mosquito is an automaton. It can afford to be nothing else. There are only about 100,000 nerve cells in its tiny head, and each one has to pull its weight. The only way to run accurately and successful through a life cycle in a matter of days is by instinct, a sequence of rigid behaviors programmed by the genes to unfold swiftly and unerringly from birth to the final act of oviposition. The channels of human mental development, in contrast, are circuitous and variable. Rather than specify a single trait, human genes prescribe the capacity to develop a certain array of traits. In some categories of behavior, the array is limited, and the outcome can be altered only by strenuous training, if ever. In others, the array is vast, and the outcome easily influenced. An example of a restricted behavior is handedness. Each person is biologically predisposed to be either left or right-handed. In present-day Western societies, parents are relatively tolerant of the outcome in their children, who therefore follow the direction set by the genes affecting this trait. But traditional Chinese societies still exert a strong pressure for right-handed writing and eating. In their recent study of Taiwanese children, Evelyn Lee Tang and her associates found a near-complete conformity in these two activities, but little or no effect on handedness in other activities not subjected to special training. Thus, in this behavioral trait, the genes have their way unless specifically contravened by conscious choice. End quote. We begin to see how we're looking at some things that are just absolute, this is how humans are. Some things that have a very wide array of options, things that can be affected by culture, things that affect culture. So we're not like mosquitoes in that we just have one course of action, but we will always have genetic influence on our tendencies and our options. He says, quote, "Even in the relatively simple categories of behavior, we inherit a capacity for certain traits and a bias to learn one or another of those available. Scientists as diverse in their philosophies as Konrad Lorenz, Robert A. Hind, and B.F. Skinner have often stressed that no sharp boundary exists between the inherited and the acquired. It has become apparent that we need new descriptive techniques to replace the archaic distinction between nature and nurture. One of the most promising is based on the imagery invented by Conrad H. Waddington, the great geneticist who died in 1975. Waddington said that development is something like a landscape that descends from highlands to the shore. Development of a trait, eye color, handedness, schizophrenia, or whatever, resembles the rolling of a ball down the slopes. Each trait traverses a different part of the landscape. Each is guided by a different pattern of ridges and valleys. In the case of eye color, given a starting set of genes for blue or some other iris pigment, the topography is a single deep channel. The ball rolls inexorably to one destination. Once the egg has been joined by a sperm, only one eye color is possible. The developmental landscape of the mosquito can be similarly envisioned as a parallel series of deep, unbranching valleys, one leading to the sexual attraction of the wing-beat sound, another to automatic blood-sucking, and so on, through a repertory of 10 or so discrete responses. The valleys form a precise, unyielding series of biochemical steps that proceed from the DNA in the fertilized egg to the neuromuscular actions mediated by the mosquito's brain. The developmental topology of human behavior is enormously broader and more complicated, but it is still a topography. In some cases, the valleys divide once or twice. An individual can end up either right or left-handed if he starts with the genes or other early physiological influences that predispose him to the left hand. That branch of the developmental channel can be viewed as cutting more deeply. If no social pressure is exerted, the ball will, in most cases, roll on down the channel for left-handedness. But if parents train the child to use the right hand, the ball can be nudged into the shallower channel for right-handedness. The landscape for schizophrenia is a broader network of anastomosing channels, more difficult to trace, and the ball's course is only statistically predictable. The landscape is just a metaphor, and it is certainly inadequate for the most complex phenomena, but it focuses on a crucial truth about human social behavior. If we are to gain full understanding of its determination, each behavior must be treated separately and traced to some extent as a developmental process leading from the genes to the final product. End quote. And so that is that is kind of a fantastic metaphor that I'm going to probably come back to through the course of the podcast, of this landscape of genetic options and the deep channels, the leading, let's say the leading channels, high on the landscape, high on the slope, and then a multitude of options taken by different environmental pressures as a person develops, so that when they're born, all the balls haven't rollen down to the shore yet. They're still in the highlands. They're only the most rudimentary beginnings of the channels have been formed. But there are still a wide array of options as to how that's going to develop more specifically as time goes by and the ball rolls to the shore and people's developmental traits become solidified as they become adults. So I thought that was a pretty interesting metaphor there. He goes on to say, quote, "The imagery of the developed landscape must be altered subtly as increasing amounts of learning and culture come to prevail on the downward slopes. In the case of language, dress, and the other culturally sensitive categories of behavior, the landscape dissolves into a vast delta of low ridges and winding oxbows. Consider, in particular, the maturation of language. There is evidence that the human mind is innately structured so as to string words together in certain arrangements and not others, according to Noam Chomsky and some other psycholinguists. This deep grammar permits a far more rapid acquisition of language than would be possible by simple learning. It is demonstrable by mathematical simulation alone that not enough time exists during childhood to learn English sentences by rote. Young children, unlike the young of any other primates, including chimpanzees, possess a fierce drive to acquire speech. They babble, invent words, experiment with meaning, and pick up grammatical rules swiftly and in predictable sequence. They create constructions that anticipate the adult forms and yet differ from them in significant details. Roger Brown, a specialist on child development, has appropriately termed their achievement the first language. Comparisons between the performance of identical and fraternal twins indicate that variation in the timing of this development depends to some degree on heredity. The upper slope in the developmental field of language is thus a relatively simple and deeply canalized terrain, but the channels of the broad lower slope, where the intricacies of the second adult language emerge, make up a shallowly etched network that ramifies in many directions. The outer manifestations of language shift with cultural evolution. They are, to a large degree, cultural evolution. The subtlest pressures from education and fashion alter vocabulary, emphasis, and tempo. But what in reality corresponds to the metaphorical ridges and channels? In some cases, behaviorally potent hormones or other biochemical products prescribed by the genes during the construction of nerve cells etch the channels. Simple compounds can alter the capacity of the nervous system to function in one way as opposed to another. Of equal importance may be the more distantly removed learning rules, the steps and procedures based on the action of particular sets of nerve cells, by which various forms of learning are achieved." End quote. So you start to get into the biology of some of this, and it's complicated, and this is in 1978, and things weren't really all that nailed down, and I don't think they were really all that nailed down today. I'm sure they're probably getting more so. But I think that it's interesting because I think science is really backing this system of predispositions toward particular behaviors that we haven't thoroughly examined and don't thoroughly understand yet. But the political implications of some of our natural traits, I think, are pretty interesting. I think that's pretty interesting how our culture evolves and our brains evolve Our culture evolves much more swiftly and in a much more controlled manner, but it's the same ultimate process by which our brains evolve and our cultures evolve. Obviously, there are differences, but they're related, and that's something that he gets to talking about soon. He says, quote, "The human mind is not a tabula rasa, a clean slate on which experience draws intricate pictures with lines and dots. It is more accurately described as an autonomous decision-making instrument, an alert scanner of the environment that approaches certain kinds of choices and not others in the first place, then innately leans toward one option as opposed to others, and urges the body into action according to a flexible schedule that shifts automatically and gradually from infancy into old age. The accumulation of old choices, the memory of them, the reflection on those to come, the re-experiencing of emotions by which they were engendered, all constitute the mind. Particularities in decision-making distinguish one human being from another, but the rules followed are tight enough to produce a broad overlap in the decisions taken by all individuals, and hence a convergence powerful enough to be labeled human nature. It is possible to establish roughly the relative strictness of the controls on various categories of behavior. Genetic studies, based on the comparison of identical and fraternal twins, suggest that primary mental abilities and perceptual and motor skills are the most influenced by heredity, while personality traits are the least influenced. If this important result is confirmed by additional studies, the inference to be drawn is that the abilities needed to cope with relatively invariant problems of the physical environment develop along narrow channels, while the qualities of personality, which represent adjustments to the rapidly shifting social environment, are more malleable. Other correlations of wide significance are suggested by the evolutionary hypothesis. The less rational but more important the decision-making process, for example, the more emotion should be expended in conducting it. The biologist can restate the relationship as follows. Much of mental development consists of steps that must be taken quickly and automatically to ensure survival and reproduction. Because the brain can be guided by rational calculation only to a limited degree, it must fall back on the nuances of pleasure and pain, mediated by the limbic system and other lower centers of the brain. We can search among the unconscious, emotion-laden learning rules for the kind of behavior most directly influenced by genetic evolution. Consider the phobias. Like many examples of animal learning, they originate most frequently in childhood and are deeply irrational, emotionally covered, and difficult to eradicate. It seems significant that they are most often evoked by snakes, spiders, rats, heights, close spaces, and other elements that were potentially dangerous in our ancient environment, but only rarely by modern artifacts, such as knives, guns, and electrical outlets. In early human history, phobias might have provided the extra margin needed to ensure survival. Better to crawl away from a cliff, nauseated by fear, than to walk its edge absent-mindedly." End quote. Yeah, we're beginning to trace the connections between behavior and culture, and this separation that I think is important as well, that he mentions between an emotional, instinctual portion of the brain that has concrete channels of, that's very hereditary, and this is how you're going to behave. Those necessary quick decisions, he says, for survival and procreation, come from a different part of the brain that is not the more slow, rational, calculating part of the brain that we're going to talk about that distinction as well in some upcoming books. I've got a lot planned out for you guys. We've got a lot of books to cover and a lot of topics. So he goes on to talk about emergence. He says, quote, "When human beings ponder their own central nervous systems, they appear at first to be in the same position as the honeybee. Even though human behavior is enormously more complicated and variable than that of insects, theoretically it can be specified. Genetic constraints and the restricted number of environments in which human beings can live limit the array of possible outcomes substantially. But only techniques beyond our present imagining could hope to achieve even the short-term prediction of the detailed behavior of an individual human being, and such an accomplishment might be beyond the capacity of any conceivable intelligence. There are hundreds or thousands of variables to consider, and minute degrees of imprecision in any one of them might easily be magnified to alter the action of part or all of the mind. Furthermore, an analog of the Heisenberg uncertainty principle in subatomic physics is at work here on a grander scale. The more deeply the observer probes the behavior, the more the behavior is altered by the act of probing, and the more its very meaning depends on the kinds of measurements chosen. The will and destiny of the watcher is linked to that of the person watched. Only the most sophisticated imaginable monitoring devices, capable of recording vast numbers of internal nervous processes simultaneously and from a distance, could reduce the interaction to an acceptably low level. Thus, because of mathematical indeterminacy and the uncertainty principle, it may be a law of nature that no nervous system is capable of acquiring enough knowledge to significantly predict the future of any other intelligent system in detail. Nor can intelligent minds gain enough self-knowledge to know their own future, capture fate, and in this sense eliminate free will. An equally basic difficulty in making a forecast of an activity as complicated as the human mind lies in the transformations through which raw data reach the depths of the brain. Vision, for example, begins its journey when the radiant energy of light triggers electrical activity in the approximately 100 million primary light receptor cells that comprise the retina. Each cell records the level of brightness or color that touches it in each instant of time. The image transmitted through the lens is thus picked up as a pattern of electrical signals in the manner of a television camera. Behind the retina, a million or so ganglion cells receive the signals and process them by a form of abstraction. Each cell receives information from a circular cluster of primary receptors in the retina. When a light-dark contrast of sufficient intensity divides the retinal cluster, the ganglion cell is activated. This information is then passed on to a region of the cerebral cortex low in the back of the head, where special cortical nerve cells reinterpret it. Each cortical cell is activated by a group of subordinate ganglion cells. It responds with electrical activity if the pattern in which the ganglion cells are discharged reflects a straight-line edge of one or the other of three particular orientations: horizontal, vertical, or oblique. Other cortical cells, carrying the abstraction still further, respond either to the ends of straight lines or to corners. The mind might well receive all of its information originating from both outside and inside the body through coding and abstracting processes. Consciousness consists of immense numbers of simultaneous and coordinated symbolic representations by the participating neurons of the brain's neocortex. Yet to classify consciousness as the action of organic machinery is in no way to underestimate its power. In Sir Charles Sherrington's splendid metaphor, the brain is an enchanted loom where millions of flashing shuttles weave a dissolving pattern. Since the mind recreates reality from the abstractions of sense impressions, it can equally well simulate reality by recall and fantasy. The brain invents stories and runs imagined and remembered events back and forth through time, destroying enemies, embracing lovers, carving tools from blocks of steel, traveling easily into the realms of myth and perfection. The self is the leading actor in this neural drama. The emotional centers of the lower brain are programmed to pull the puppeteer's strings more carefully whenever the self steps onto the stage. But granted that our deepest feelings are about ourselves, can this preoccupation account for the innermost self, the soul, in mechanistic terms? The cardinal mystery of neurobiology is not self-love or dreams of immortality, but intentionality. What is the prime mover, the weaver, who guides the flashing shuttles? Too simple a neurological approach can lead to an image of the brain as a Russian doll, in the same way that we open one figure after another to reveal a smaller figure until nothing remains. Our research resolves one system of neuron circuits after another into smaller subcircuits until only isolated cells remain. At the opposite extreme, too complex a neurological model can lead back to a vitalistic metaphysics, in which properties are postulated that cannot be translated into neurons, circuits, or any other physical units. The compromise solution might lie in recognizing what cognitive psychologists call schemata, or plans. A schema is a configuration within the brain, either inborn or learned, against which the input of the nerve cells is compared. The matching of the real and expected patterns can have one or the other of several effects. The schema can contribute to a person's mental set, the screening out of certain details in favor of others, so that the conscious mind perceives a certain part of the environment more vividly than others and is likely to favor one kind of decision over another. It can fill in details that are missing from the actual sensory input and create a pattern in the mind that is not entirely present in reality. In this way, the gestalt of objects, the impression they give of being a square, a face, a tree, or whatever, is aided by the taxonomic powers of the schemata. The frames of reference serves to coordinate movement of the entire body by creating an awareness and automatic control of its movable parts. He goes on to say, quote, "Most significantly of all, schemata within the brain could serve as the physical basis of will. An organism can be guided by its actions by a feedback loop, a sequence of messages from the sense organs to the brain schemata, back to the sense organs, and on around again until the schemata satisfy themselves that the correct action has been completed. The mind could be a republic of such schemata, programmed to compete among themselves for control of the decision centers, individually waxing or waning in power in response to the relative urgency of the physiological needs of the body being signaled to the conscious mind through the brainstem and midbrain. Will might be the outcome of the competition, requiring the action of neither a little man nor any other external agent. There is no proof that the mind works in just this way. For the moment, suffice it to note that the basic mechanisms do exist. Feedback loops, for example, control most of our automatic behavior. It is entirely possible that the will, the soul, if you wish, emerged through the evolution of physiological mechanisms. But clearly, such mechanisms are far more complex than anything else on Earth. So, for the moment, the paradox of determinism and free will appears not only resolvable in theory, it might even be reduced in status to an empirical problem in physics and biology. We note that even if the basis of the mind is truly mechanistic, it is very unlikely that any intelligence could exist with the power to predict the precise actions of an individual human being, as we might, to a limited degree, chart the path of a coin or the flight of a honeybee. The mind is too complicated a structure, and human social relations affect its decisions in too intricate and variable a manner, for the detailed histories of individual human beings to be predicted in advance by the individuals affected or by other human beings. You and I are consequently free and responsible persons in this fundamental sense. And yet our behavior is partially determined in a second and weaker sense. If the categories of behavior are made broad enough, events can be predicted with confidence. The coin will spin and not settle on its edge. The bee will fly around the room in an upright position, and the human being will speak and conduct a wide range of social activities characteristic of the human species. Moreover, the statistical properties of populations of individuals can be specified. In the case of spinning coins, there is no need for computers and other paraphernalia to make statistical projections exact. The binomial distribution and arc sine laws governing their behavior can be easily written on the back of an envelope, and these mathematical formulas are rich with useful information. At another level, entomologists have produced detailed characterizations of the averaged flight patterns of honeybees to flowers. They know in advance the statistical properties of the waggle dance the bees will perform to convey the location of the flowers to nestmates. They have measured the timing and precise distribution of errors made by bees acting on that information. To a lesser and still unknown degree, the statistical behavior of human societies might be predicted given a sufficient knowledge of human nature, the histories of the societies, and their physical environment. Genetic determination narrows the avenue along which further cultural evolution will occur. There is no way at present to guess how far that evolution will proceed." End quote. And that's pretty interesting. It's impossible to predict any particular person because they're so complex. The human being is so complex, and the society becomes, significantly more complex by the interaction of so many complex creatures. But it becomes an issue of statistical measurement because there are so many components that are all similar enough in being human beings that there can be a statistical prediction of what society will do. That's pretty interesting. He says, quote, "In my opinion, the key to the emergence of civilization is hypertrophy, the extreme growth of pre-existing structures, like the teeth of the baby elephant that lengthen into tusks, and the cranial bones of the male elk that sprout into astonishing great antlers. The basic social responses of the hunter-gatherers have metamorphosed from relatively modest environmental adaptations into unexpectedly elaborate, even monstrous forms in more advanced societies. Yet the directions this change can take, and its final products, are constrained by the genetically influenced behavioral predispositions that constituted the earlier, simpler adaptations of pre-literate human beings. Hypertrophy can sometimes be witnessed at the beginning. One example in its early stages is the subordination of women in elementary cultures. The Kun-san of the Kalahari Desert do not impose sex roles on their children. Adults treat little girls in apparently the same manner as little boys, which is to say with considerable indulgence and permissiveness. Yet, as the anthropologist Patricia Draper found during a special study of child development, small average differences still appear. From the beginning, the girls stay closer to home and join groups of working adults less frequently. During play, boys are more likely to imitate the men and girls are more likely to imitate the women. As the children grow up, these differences lead through imperceptible steps to a still stronger difference in adult sex roles. Women gather mongongo nuts and other plant food and fetch water, usually within a mile of camp, while men range farther in search of game. But Kung social life is relaxed and egalitarian, and tasks are often shared. Men sometimes gather mongongo nuts or build huts, women's work, with or without their families, and women occasionally catch small game. Both sexual roles are varied and esteemed by all. According to Draper, Kung women maintain personal control over the food they gather, and in demeanor they are generally vivacious and self-confident. In a few localities, bands have settled into villages to take up farming. The work is heavier, and for the first time in known Kung history, it has come to be shared by a significant extent by the younger children. The sexual roles are noticeably hardened from early childhood onward. Girls stay even closer to the home than previously in order to care for smaller children and perform household chores. Boys tend herds of domestic animals and protect the gardens from monkeys and goats. By maturity, the sexes have diverged far from one another in both way of life and status. The women are more fully domestic, working almost continuously at a multiplicity of tasks in which they are supervised. The men continue to wander freely, taking responsibility for their own time and activities. So only a single lifetime is needed to generate the familiar pattern of sexual domination in a culture. When societies grow still larger and more complex, women tend to be reduced in influence outside the home, and to be more constrained by custom, ritual, and formal law. As hypertrophy proceeds further, they can be turned literally into chattel, to be sold and traded, fought over, and ruled under a double morality. History has seen a few striking local reversals, but the great majority of societies have evolved towards sexual domination as though sliding along a ratchet. Most, and perhaps all, of the prevailing characteristics of modern societies can be identified as hypertrophic modifications of the biologically meaningful institutions of hunter-gatherer bands and early tribal states. Nationalism and racism, to take two examples, are the culturally nurtured outgrowths of simple tribalism, where the Nye Kung speak of themselves as perfect and clean, and other Kung people as alien murderers who use deadly poisons. Civilizations have raised self-love to the rank of high culture, exalted themselves by divine sanction, and diminished others with elaborately falsified written histories. Even the beneficiaries of the hypertrophy have found it difficult to cope with extreme cultural change, because they are sociobiologically equipped only for an earlier, simpler existence, where the hunter-gatherer fills, at most, one or two informal roles out of only several available. His literate counterpart in an industrial society must choose 10 or more out of thousands, and replace one set with another at different periods of his life or even at different times of day. Furthermore, each occupation, the physician, the judge, the teacher, the waitress, is played just so, regardless of the true workings of the mind behind the persona. Significant deviations in performance are interpreted by others as a sign of mental incapacity and unreliability. Daily life is a compromised blend of posturing for the sake of role-playing and of varying degrees of self-revelation. Under these stressful conditions, even the true self cannot be precisely defined, as Irving Goffman observes. There is a relation between persons and role, but the relationship answers to the interactive system, to the frame in which the role is performed, and the self of the performer is glimpsed. Self, then, is not an entity half concealed behind events, but a changeable formula for managing oneself during them. Just as the current situation prescribes the official guise behind which we will conceal ourselves, so it provides where and how we will show through, the culture itself prescribing what sort of entity we must believe ourselves to be in order to have something to show through in this manner. End quote. Little wonder that the identity crisis is a major source of modern neuroticism and that the urban middle class aches for a return to a simpler existence. End outer quote. That's a nice moment there where he looks at the complexity of modern life and the number of different roles we have to fulfill. But hypertrophy is the core concept introduced there, how our modern societies have taken basic biological drives and the systems that we have built to adapt to them and to accommodate them have spawned additional systems, and the entire culture just builds up basic drives into overdrive and creates all of culture out of complicated extensions of basic instincts. So that's a cool concept of hypertrophy. And that is as far as I'm going to go in that book. I've read quite a bit of it. So to review, we talked about the landscape and the initial, more simple and guided, deeper, I guess you could call them, channels of directed behavior, breaking out into more complex and subtly changeable routes, but all stemming from one particular direction, and given that initial direction by the initial channel. I think that's a cool metaphor. So we got to see that. We got to see hypertrophy, the extension of these biological traits into cultural. So it's kind of one almost runs into the other, you know? So it becomes a question of, as the ball is kind of rolling down the landscape, where genes end and environment begins. And it's not easy to put a line there and define that. So I think that's one of the core concepts of the book. Anyway, it's a great book, and we'll be exploring this topic in more detail in future books. So check out the Facebook page at facebook.com/neofusionist. You can find me on Patreon. You can find me on Twitter by searching for Neofusionist. I'm on iTunes, Google Play, however you want to find me, YouTube. And I always appreciate feedback, so thank you all for listening, and I'm going to close it up now. Later.